The most important continuous probability distribution is the normal distribution. Now, we've looked at it before, but we will cover it in more depth in this chapter. So the normal distribution is also called the bell curve or the Gaussian distribution. And it's symmetric about the center. The mean is equal to the median is equal to the mode. The total area under the normal curve is equal to 1. The normal curve approaches, but never touches, the x-axis. The inflection points are at the mean minus the standard deviation and the mean plus the standard deviation. So 1 standard deviation away from the mean in both directions. And inflection points are where the graph changes from curving upward to curving downward. And many things in life are normally distributed: human height, shoe sizes, blood pressure, test scores, and many more. And this is the empirical rule which we already worked with. So approximately 68% of the data falls within 1 standard deviation of the mean, 95% of the data falls within 2 standard deviations of the mean, and 99.7% of the data falls within 3 standard deviations of the mean. And data that lies more than 2 standard deviations away from the mean is considered unusual. As a normal distribution moves to the right, the mean increases. As a normal distribution spreads out, the standard deviation increases. So on number 1, we have 3 different graphs, and it asks which normal curve has the greatest mean. So the means are here, here, and here. And again, as we move to the right, the mean increases. So this would be normal curve C. Which normal curve has the greatest standard deviation? Curve A is the most spread out. So curve A has the greatest standard deviation.